airplane mode on, it would still work. And so there's some really magical experiences that people are starting to create with artificial intelligence or machine learning. You think of, if you apply that to accessibility, for instance, what does that mean if people are hearing impaired? Or what does that look like if you're in a foreign country and you actually don't speak the language? Are you able to have what we call multimodal communication, meaning that I can communicate with you in whichever method is best for me, and you receive it in the best method for you? You get this really, really powerful use cases for that. And there's tons of other ones in education and healthcare, for instance, but those are just a few that I'll.
All right, so what hasn't been touched on? Actually, I just want to reinforce something you said, serendipity. When you guys go to a site, when you have a certain experience and somebody contacts you at the right time, there's quite a good chance that there might be an algorithm behind that. If the person contacting you or the website was like, off of all of this data on you, like this is our decision, that would be a pretty bad experience, right? So a lot of companies aim for serendipity, so I think that's amazing. I like that point a lot. The only other thing, broad class of problems that I think touch people every day. Have you ever made a purchase at a unusual place and then all of a sudden your credit card goes through like a flag? Yeah. That's something called anomaly detection, right? So there's an understanding of what is your current behavior, the typical things that you do, how we think about that. But once you trigger an anomaly, when you do something unusual, there's an immediate shutdown of that credit card, at least a pause on it. And that's another way that algorithms impact your life. Another thing that Google launched that I think a lot of people are using, how many of you have Pixels? All right. Has it?
Not yet.
Not yet. Portrait mode, I believe, is using neural networks.
Site, Top Shot. Actually, and most of those are actually some Top Shot Google Blend suggestions. A lot of those are also, they're actually built by our team.
Sorry. A lot of those are actually built by our team and also are continuing with this premise of trying to create privacy-preserving AI that provides really interesting experiences. So Top Shot is a feature that if you took a photo to say it's at a birthday and you wanted to get your kid blowing the candle out, right? Today, you have to make sure either you just press the button a lot, or you just hope to God that you captured it at the right moment, right? The eyes aren't closed, or someone's not sneezing, or something weird's happening in the background. Top Shot actually starts to learn, we've trained the model so that it starts to learn the intent of the photo, so that it actually takes the right photo, the photo that you intended, not necessarily the photo that you actually did when you clicked the button. And so there's some really, I guess, like you go to your point, I think there's some really interesting use cases that are being created in a very serendipitous fashion, right? I mean, you feel like you are the best photographer, but you're not, right? Right? Like, and so I mean, it really augments your experience and use of some of these devices in a way that previously was not possible. And so,
Pandora, a lot of music services also aim for that serendipity, and they're using a variety of different behaviors to figure out the next song.
Very, very cool. It paints a really broad brushstroke in terms of what you guys have shared and how it's being used. Let me just continue on that for one more moment. Are you seeing differences in what a large company, a Salesforce or Google or someone else, is able to do with a research staff and others versus maybe a smaller or medium-sized company? And so what's different? And if you're a smaller shop, is there anything you can take advantage of in terms of AI tools and solutions?
Yeah, I think smaller shops will tend to have a bit more focus, and sometimes focus on two things. One, the problem at hand, and keeping the doors open. So I could see smaller shops often having a higher efficiency in putting things out. Also, if you are not fully committed to, let's say, SageMaker or AI Hub or somebody else's offering, you can sample from everything out there. So I think they can become a little bit disruptive through merging of technologies. The big companies, I think, are always going to be able to put a lot of dollars into kind of the cutting edge, pulling academics out of the lab and still creating that academic type lab.
So one of the other big differences is if you're a startup, right? The biggest hurdle for you is trying to achieve product market fit, right? So you're trying to get to your MVP, right? Your minimum viable product, and it's supposed to be viable, not just minimum product. And you are laser focused on delivering that. What's interesting is that if you talk to startup founders today, they often say they want to leverage AI, but in the future. The problem with that is that if you're not structuring your organization, your product in a way that will allow you to collect the data that you need to use to make predictions in the future, you can't just turn on the AI switch. You just can't say, I have no data, but all of a sudden I'm going to make recommendations now. That's not how the systems work. And so either you're going to have to change the system from that point and then turn it on, or you have to change your product to be able to collect that data at that point. And then after you've collected enough data, turn on the AI funnel or the functionality. Or you have to think about the fact that you almost have to future-proof your product early and say, how am I thinking about the data that I need to be able to make these predictions in the future, even though my product may not be there yet. That affects the types of forms you have people fill out, the types of track. I mean, there's so many different components that go into this, and you don't have to go do some super elaborate, Google scale effort, but it is something that you have to be thoughtful of at the time you are making your first iterations of your product. And I think that's one of the big differences, is that Google has a ton of data already, and so for us to be able to spin up a new project, it's fine, we have so many different data stores, right? But if you don't have that, you can't. There are data stores you can use, but you really want to make sure you have the right data, because if you don't have the right data, the model will not work the right way.
I just have to say, y'all put together a lit panel. I mean, all of these answers are so complimentary and filling in different gaps. Like, it's so rare to get a panel that well put together. And so what I want to add is there are still so many companies that are not even collecting data, that are operating on paper. And I'm sure many of you will at some point, especially if you're doing consulting, will come in contact with one of those companies. And some people were like, well, they're not even collecting data, so AI is not even a conversation we can have. No, AI is still a conversation you need to have, because the structure that you put in place for their data collection today can be so much better than the structure you would have put in place 10 years ago when you didn't know that AI was the ultimate goal. So that's one thing that no matter what company you're working with or supporting, you need to understand what the common business processes are, and as you're moving them from a paper-based company to a data-driven company, you're making sure that you're putting in place the architecture, the data architecture, and the systems architecture that will enable them to move to predictions quicker than people who are still trying to fix their broken and busted data systems, which is a lot of people. Then in terms of working with large companies versus smaller companies, this has been so fun for me, because I actually worked in, I was a technical solution engineer, so I worked with a lot of companies, helping them put in place their data systems that were both small as well as large. It's interesting, when you say small company, a small company can be a company like Hulu, right? Which is a very common brand, it's a consumer brand, but they don't have 50,000 employees like an Intel, or 100,000 employees like a Microsoft. They still qualify as a small company. They may have 10,000 employees or less. So if you think about a company like that, they're still going to have a lot of talent. They're probably doing lots of data, but they're probably still not ready to take on AI projects. So they're trying to figure out, what are the most viable AI solutions for me to put in place? They're also at a stage where they're less likely, they're big enough that they definitely don't want to reinvent the wheel and build up a whole team just to manage some AI project. So they're more likely to go out and look for a solution that they can buy off the shelf. So you want to think about the company size and whether they're going to have creative, experimental type people who are just going to go out and do things, and they're not going to have a legal team to slap their hand and say, no, don't do that, we're going to get in trouble. And those are usually some of the very, very small startups. They have 500 employees or less, 1,000 employees or less. And they're going to be more willing to do experimental things. But they won't be able to do a lot of things. It's going to be like 1 or 2 things that they're going to be able to do. And when you go in the really big size, you look at a company like Farmers Insurance, again, another household name. They have lots of talent, they have lots of data, but guess what? They're going to have to move really, really slow because they're highly regulated. They don't want to get in trouble, and they have lots of politics, so that's going to slow them down. So if you're going to work with a company like that, or at a company like that, and try to implement AI, what you're going to have to really think about is, how can I create the right stakeholder relationships with people so that I can actually get something funded and get it, released to my customers. So there's like a lot of different kind of swim lanes that you can break these different companies down into based on their readiness to adopt technology, the size of their company, whether they're heavily regulated or not, and whether they have a first mover instinct for innovation.
I'll just piggyback on what some of the panelists have said. I think the strategic advantage of a large company with respect to AI or machine learning is having data. Even between large companies, the company that has the data and has the best data is the one that's going to have the strategic advantage. And if you're a smaller company, you just don't have the resources to collect the data, to store it, to clean it. So it's not just, when I say best data, you can have a bunch of data centers full of data, but if it's not the right type of data, if it's not clean, we have something called clean in our industry, where a lot of the, when you hear about data scientists and what do they do, a lot of the work of a data scientist, at least my work, is taking data and cleaning it, making sure that we can then put it into an algorithm and train the algorithm. And there are large industries now just devoted to collecting data and cleaning the data. Companies like Figure 8, Mechanical Turk, are ones that smaller companies, even large companies, go to and say, hey, we need to get this data, or we already have a bunch of data, can you clean it for us? Can you collect the data for us? Yeah, that's what I would say. Okay.
Thank you all for that. I'm going to actually jump around a little bit, so hopefully I'll be able to stitch it back together, but you gave me the perfect entree, and I want to take advantage of that. And that is, can you help us understand what some of the different roles are, right? Because we hear terms like data scientists, data analysts, machine learning engineer, whatever it happens to be. What do they all mean? And what does that mean to folks in this room who are perhaps looking to either get involved with AI, whether on their own or in a company or in a different company or in some other role? What's the right way to be thinking about kind of this AI talent pool that's out there?
Okay, well, I would say that some of the main roles, the ones you mentioned, data scientist, machine learning engineer. So data scientist is a term that is a lot like AI. There's no real standard for it. If you talk to 1,000 companies that have data scientist requisitions or data scientists, they're trying to hire data scientists, you ask them what they want, they're gonna have 1,000 different answers. So that's a wide-ranging term. But basically, I'd say the core skills of a data scientist would be someone who understands machine learning algorithms, someone who understands data systems and how to clean data. So someone who knows like SQL, for instance. And someone who knows how to apply those to a real business problem. So there's also machine learning engineers, people who are more focused on specific machine learning algorithms. So folks, for example, who know about deep learning algorithms and what platforms, software platforms work best to build them on. There's also another class of person called a data engineer, someone who builds the platforms to take data from a raw state through, to clean it up, take it through an algorithm, and then output it to a real business response or a real business, an output that has some real business value.
Yeah, and I like your answers because you notice all the roles that he mentioned were technical roles, highly technical roles, and many of these are new titles that most people haven't heard of up until the last 5 years. And that's a huge challenge because what often makes companies successful with crossing the chasm of a new innovation technology, right? Getting something from experiment to like, this is actually producing results and now everybody wants it and it's the best practice. Those are traditionally, in my opinion, business analysts. People who understand the business and they understand the technology landscape and they can close that gap. So one of the things I'm doing now is, which is why I really love talking to you all in this audience, is really helping the business folks in the space understand all of that stuff, understand who those people are, understand all those technical terms, what we're talking about, and how it actually really relates back to your business. And unfortunately, this is a problem that isn't being well addressed right now in the training market, which is why I'm launching AI Newbies and focusing specifically on non-technical business people, because without this mass group of people understanding this thing, it's just not going to go anywhere, or it's going to move really, really slow, or you're going to end up with 5 key players managing everything, and it's going to look like what I call FANGs, which is Facebook, Amazon, Netflix, Google, and Salesforce. and there are a lot more companies out there than those 5. So we need to create the wave of education that is going to reach people who don't have a degree in data science and who've never written a line of code, enabling them to actually do powerful things with AI.
This is a touchy subject for me because I studied psychology, so I don't have a CS background, Google is an interesting company in that they over-index on the technical stuff, strongly over-index on the technical stuff. What that means is that you missed all the gems that live in the context because you don't know the space. Right? You are not the subject matter expert. And oftentimes when we talk about AI and we talk about engineering, we forget about how important it is to truly understand your user, right? To truly understand the space, to truly understand the impact of decisions, right? I was the seed member of the US applied healthcare team for DeepMind. So I was building up the first engineering team here, and I was trying to help us figure out what should Google do in healthcare, particularly around AI. One of the biggest challenges is finding the right people. So we had to make sure that we had clinicians on staff. We're not contractors, they were full-time employees, because we cannot, we're engineers, we're technical program managers, we're business folks, we are not doctors. And it's important to make sure that those folks are included in the room while you are making the technology. It's not enough to run it past them once you build it. They have to be fundamentally equal stakeholders while you're building the thing. So your UX folks, your subject matter experts are people that we cannot forget to include in these types of conversations, because I think it leads us down a path that is potentially dangerous, because you get to this point where you go, oh, well, I didn't know the consequence would be X, right? And accountability and like AI is a whole nother subject, but you really do get into some of those spaces and you wonder, like, how did they mess up? This doesn't make sense. It's all because people didn't have the experience. So that happens quite a lot, but I think it's really important for AI.
So most of this will be a recap. We heard DS, machine learning engineer, data engineer, BA. I'm going to add to that product managers as well, right? Subject matter experts and user experience researchers. I couldn't agree more with all of those. There's also a role for project management. A lot of AI projects are incredibly unusual in that there is a very high likelihood of failure. If you are a project manager that can deal with that, you are a diamond in the rough and you will be loved by data scientists and the people that are working on the cutting edge.
Cool. Thank you. I'm going to come back now to the more interesting side of AI. So this might be a little bit more of a difficult question. But there's been a lot of advancements out there. We've talked about a few of them tonight. So Keita mentioned, for example, object detection. Yet in March, some researchers out of Georgia Tech have published a paper that showed that self-driving cars, the models that they're trained on, actually have a propensity to fail to properly detect people with darker skin. So that can be a problem for people of color in a crosswalk or stepping in front of a car, something like that. We also found, I forgot exactly which publication it was in, where we're making some great strides in being able to use some sort of medical device. I'm holding up my phone, but something that takes a photo of, let's say, an interesting mole on your skin and will detect it, classify it as cancerous or not cancerous. And again, what we're finding is that that doesn't work with the same type of accuracy with people with darker skin. So we look at things like that. We also see systems, so not even things that are trying to classify based on something, let's say, visual. So let's say something that had a positive intent, right? So there was a system that was rolled out to correctional facilities that was designed to minimize, to reduce the amount of racial bias when it came to sentencing or determining if someone would get paroled, right? So he wanted to try and take race out of the equation. Yet after deployment and use, they actually found that it was as biased as the data it was trained on. So it really didn't do what it was intended to do. And I'm going to just end with a quote from the periodical The Atlantic, and then I'd like to ask for all of your perspectives and just response. But their quote is, "Racial disparities in artificial intelligence and machine learning are not a new issue. Algorithms have mistaken images of black people for gorillas, misunderstood Asians to be blinking when they weren't, and judged only white people to be attractive." So I'd like to just understand, in the context of the positives that we've talked about tonight, your perspective on some of these challenges that we also see in the AI solutions that are out there.
So two things about AI. One, it solves a single problem. And another way to think about it, imagine it as kind of a small child, right? What you put in is what you're going to get out. If you have a sample that has bias built into it, it's going to perpetuate with whatever patterns it's already seeing. So the words like recidivism, or you see that often in kind of detection for like who should be paroled, who should not be paroled. It's essentially just running back the patterns that have been built into it. So that would probably be a questionable target for something unless you actually wanted to perpetuate those patterns again. When computational vision can differentiate between somebody who's not in the data set, it's not necessarily a failure of the algorithm itself, it's a failure of the data set, or it's a failure of the practitioner. We saw this also very early on with Siri couldn't understand accents. It's the same theme, in my opinion.
Yes. I could talk about like machine learning fairness and bias all day. You can't layer machine learning on top of inequity and think it's going to solve it. And we have layers and layers and layers and systems upon systems upon systems of inequity in everything. So you can't just sprinkle it on top of a recruiting system and imagine that somehow it's going to fix the bias that is your entire recruiting pipeline, interview process, and hiring process, and compensation process, and like, it's not, right? And so I think the difficulty is being able to take a step back and figure out first, like, where are we failing? Which is a whole another problem. So I think there are a lot of layers that you have to kind of go through. And I do think it's possible, but it has to be done with explicit intent. You can't just assume that it's going to fix it. I do think it's possible to use these types of technologies to actually improve things. But I do think it will require someone in a team to say, oh, these are the types of metrics that we need to make sure we avoid. And to do that, you often need people who have a perspective that is not the homogenous group that typically is our product teams, right? And so there's lots of problems that have to get fixed for, I think, for us to actually move the needle here. But you know, you identified it earlier. It's garbage in, garbage out, which is, you know, a phrase that you will hear time and time again from machine learning teams.
So this problem exists on multiple levels, right? It exists on the level of the type of problem you're trying to solve and how you're trying to solve it. So if you take recidivism, for example, and if you turn that problem around and instead of trying to predict who is likely to recidivate, right, recommit a crime and end up back in the court system, if you instead looked for what are the factors that would prevent recidivism, you can then actually get useful data out across all of those different groups, regardless of their racial demographic or their zip code. So it's not just, is the data set biased or not, it's what are the questions I'm asking of my data set? Am I asking the right question of the data set? So that's the formation of the question, then the data set itself. Then there's another level that's even deeper, and people don't want to talk about this. So you see my face got all serious. I'm not, no more smiles from Ayori. Everyone's in trouble now. Specifically looking at algorithms like the ones that run sentiment. You know, when those, there is a specific algorithm that is used to drive almost every sentiment engine that is commonly adopted today. You will find the same issue in Salesforce's algorithm, and Amazon's algorithm, and in Google's algorithm. And ultimately, if you put my name, Ayori, which is an uncommon name, or Shaquanda's name in a sentence, and you use that same sentence when you put Adam or Jane, you're going to get a positive or a negative sentiment, a percentage of positive or negative sentiment on that based on only the difference of the name. That's a problem. Why does that exist? The original algorithm was built with a collection of names like Adam and Jane and Bobby and Richard, right? There's no Lee in there. There's no Ricardo in those data sets that created the original algorithm that we're now training every algorithm on. Look, we as a data science community are responsible for that failure. We have not regulated our algorithms that we are then trying to deploy across everyone else and say, you should standardize on this. That's our problem. And I think ultimately, a lot of us are ashamed about it, and we're not talking about it. And that needs to stop, because you can't fix it if you hide it.
Yeah, so this is a very serious problem. We even see right now that algorithms are being deployed by the police departments that have this bias, and it's going to have negative effect unless we can really do something about it. I think there are 3 areas of solution for this. To have transparency in your algorithms, to have some regulation, and to have some standards. So transparency, what does that mean? So going back to my first example of a nonprofit, I made predictions about what people they should call. So the first pass, I gave the client the algorithm. I said, okay, here you go. I thought I could collect my check and go away. But he said, no. Why did it make this decision? Why did it tell me to pick out this person? Why did it tell us to call that person? And so it challenged me to go and find some other tools to help to add interpretability and explainability to the predictions that my algorithm came out with. So you have some algorithms that are called black box. You put some data in, it spits out an answer. The answer may be highly accurate, but you don't know why it came to the answer. There are others now that can employ interpretability and explainability. You put some data in, when it gives you an answer, it can tell you why, what factors led to that answer. So adding that set of tools to algorithms can help this transparency. Regulation. So in the EU now, there's a rule or a law that if an algorithm results in an adverse result to you, let's say you get a high insurance rate or something because they put your name through an algorithm or your profile through an algorithm, you have the right to know why. So if an algorithm makes some decision about you that results in some adverse effect to you, you have the right to know why. So we have to put pressure on our representatives to have similar regulations, this is my opinion. And the third is to have standards. There's some good work coming out of MIT by a member of a Black in the AI group. Her name is Joy. Her last name is
Joy Bulawani.
Thank you so much. So she's done some great work, and she has a set of standards actually for a certain type of algorithm. One application of which is to recognize faces, and so these are used by police departments, for instance. And she has put the systems by some of the big companies like Amazon, Google, and IBM against a set of standards, and shown that, for example, women who have dark skin are going to be less, it's going to be less accurate in identifying those types of people. So just having a set of clear standards that companies can hold their systems to will also do a lot in shining light on this problem.
In the space of standards, has anyone heard of Shirley cards? No one has heard of Shirley cards? Okay. I would look up Shirley cards. It's really interesting. So we talk about how come cameras don't pick up dark skin, or why does my camera work as well? When you start talking about standards, when you have baseline technology, it's not enough just to have the standard, right? It has to be good standards, right? Because if you're basing it based off of a blonde hair